Hey there, and welcome to The Explainer. Today, we're diving into a world you can't see, a hidden reality that, believe it or not, controls literally everything around you. Everything you can touch, see, and feel. So let me ask you something. Have you ever wondered why you can pile up sand, build a sandcastle, but you can't do the same thing with water? I mean, why does one thing hold its shape while the other just splat turns into a puddle? Well, the answer to that little mystery, it's all tied up in that hidden reality I mentioned. Think of us as detectives. We're about to go on an investigation together to uncover the invisible rules that run the show for everything, from a hard rock to the very air you're breathing right now. And our first clue is right here. It's something super simple, a piece of chalk. You wouldn't think it, but this humble little thing holds the key, the very first major clue to understanding what matter, what stuff, is actually made of. Okay, so this is our first big breakthrough. The evidence we're about to see points to a pretty wild idea, that all the things we see as solid, as one continuous piece, well, they're not. They're actually made up of tons and tons of tiny little parts. Just think about it, right? You take a stick of chalk, you can snap it in half. Then you can break those pieces into even smaller pieces. You can even grind them all the way down to a super fine powder. But here's the kicker. That powder, every single tiny grain is still chalk. The stuff itself hasn't changed, just how big the pieces are. And that tells us something huge. The chalk has to be made of these countless, identical, tiny units. And there's a name for this, of course. Scientists call it a constituent particle. Really? It's just the basic building block of any substance. It's like how a wall is made of a bunch of individual bricks. That stick of chalk, it's made of a gazillion of these tiny constituent particles. Okay, so that makes sense for something solid, like chalk. But what about this little puzzle? You take some sugar, you stir it into a glass of water, and poof, it's gone. It disappears. So where did it go? Did those sugar particles just cease to exist? Nope. And the answer is our second huge clue. The sugar particles are absolutely still there. They've just broken up into their own individual particles, and these are so incredibly tiny that they've slipped into empty spaces that were already there right between the water particles. So get this, matter isn't just made of particles. It's also got empty space in it, gaps. Okay, so now we've got two major pieces of the puzzle, right? That everything is made of particles and that there are spaces between them. And what's amazing is that these two simple ideas, well, they're pretty much the rules of the game for the entire physical world. Let's give them their proper names. The first one is what we call interparticle spaces. A bit of a mouthful, but it's just those empty gaps we saw the sugar sneak into. And it turns out that every substance, I'm talking solid, liquid, or gas, has these little empty spaces between its particles. And the second rule? That's interparticle attractions. I mean, if everything has these empty spaces, you gotta wonder, what holds it all together? Why doesn't everything just fall apart? Well, that's where these invisible forces come in. They're kind of like tiny little magnets, constantly pulling the particles together and holding a substance, like our stick of chalk, in one solid piece. And this idea that everything is made of tiny particles, it's not new at all. This is a question people have been wrestling with for centuries. In fact, thousands of years ago, an ancient Indian philosopher named Acharya Kanad came up with this concept of Paramanu, the idea that everything is made of these tiny, eternal, indivisible particles. Just amazing to think about. All right, now for the payoff. Let's see how these two rules, spacing and attraction, actually work together. Because with these two ideas, we can finally solve that original mystery. Why are solids, liquids, and gases so fundamentally different from each other? Here's the key. It's all a balancing act. In a solid, the particles are jammed together, packed super tight. And that attraction between them, it's incredibly strong. This basically locks them into place, which is why a solid has a fixed shape. But in a liquid, while the particles are still pretty close, that attraction is much weaker. This lets them sort of slip and slide past each other. And that's why water flows. And this just shows you how different that attraction can be. Think about it. To melt ice, to break those bonds, you just need to get to 0 degrees Celsius. But to melt a chunk of iron, you need to crank the heat up to over 1,500 degrees. That's how much energy it takes to overcome the crazy strong forces holding those iron particles together. So what's the deal with gases? Well, in a gas, the particles are super far apart. I mean, so far apart that the attraction between them is basically zero. They're totally free. They just zoom around like crazy, filling up whatever container you put them in, no matter how big.
Okay, but wait. There is one final piece to this entire puzzle, and it's a big one. Those particles we've been talking about, they're not just sitting still. Not at all. They are all, always, in constant random motion.
Ever wonder how you can smell something cooking or maybe an incense stick from all the way across the room? How does that actually happen? Well, those little fragrance particles get released into the air and they start moving. They immediately start bumping into all the air particles, which are also zipping around, and this collision fest just knocks them all over the place, spreading that scent until it's everywhere. It's like this completely chaotic, totally invisible dance happening all around us. So let's put it all together. Here's the whole shebang. In a solid, you've got the tiniest spaces and the strongest attraction, so the particles are locked in and can only kind of vibrate. In a liquid, you've got more space and weaker attraction, which lets the particles slide around. And in a gas, you've got max space and basically zero attraction, so the particles just go wild and fly freely. It's such a simple, elegant system, but it explains so much. When you boil it all down, it comes back to this one single, powerful idea that explains our entire physical world. Everything you see, even you, is just a massive collection of tiny, constantly moving particles all held together by these invisible forces. That's it. And that leaves us with one last kind of mind-bending question to chew on. If a chair is nothing but its particles, what would be left if you could just, poof, magically snap your fingers and make all of those particles disappear? What's left? Nothing, right? Anyway, something to think about. Thanks for joining me on this Explain.